Number 3. F of x is equal to x minus 2 times, x minus 2 squared times x plus 1. So we're going to graph this function. That's what they ask us to do. So let's do that. The easiest place to start, especially since this is already factored, is put some x-intercepts on there, which is where the zeros will be found, right? So what are the zeros here? Well, we got, if we were to set this equal to 0, we would find x minus 2 squared equals 0, or x plus 1 equals 0. We could take the square root of both sides. That could make it easy. X minus 2 is equal to 0, so x equals 2, or x equals negative 1. These are our zeros. So at 2 and negative 1, we find zeros. Okay, that's great. Here's our dilemma. How do we draw the rest of it, right? All we know right now is that there are these x-intercepts, so I could draw this. That would go through those x-intercepts. I could draw this. That would go through there. I could draw this. You get my point, right? Any number of these has those x-intercepts, but only one of them or none of these could be the graph of this function. So how do we get a better idea of what this graph looks like? We just need some more points. We need some more data. So let's create an XY table. Now, how many points is enough? That's a good question. Well, really, what we're trying to get an idea for here is, does the graph come from down here and cross through this x-intercept? Does it come up here and touch this x-intercept and go back down? And likewise for this one, does it come from up here and cross? What's going on? How does it interact with this x-intercept? Right? If we could just know how it interacts, if it crosses from here to there, or crosses from here to there, or touches down here, that would put us a lot farther ahead than just guessing, just out of the blue. So how about if we just kind of break these up into little sections and say, if I just knew what was happening over here and over here, that way I would know that it crosses like this, or if I had a point here and here, I would know that it goes like that. So let's plot 3 points, one here, and one here, so that we know what's going on either side of an x-intercept, and we can definitely get a good idea of what this looks like. So let's put in a negative 2. That's right here. And let's put in 0. That's easiest. If you can use 0 at some point, that's great, because that makes things so much easier, typically. And then we'll put in a positive 3. Okay. Yeah, so let's just do that. So x is going to be negative 2 now. We're putting negative 2 in for x. X minus 2 squared times x plus 1. What do we have here? We have negative 2 minus 2, that's negative 4. Negative 4 squared is 16. We multiply that by negative 1, so we get negative 16. There we go. 0 minus 2 squared. We're putting in a 0 now. I've moved on to that. 0 plus 1. So we have negative 2 squared, that's 4. We're going to multiply that by 1, so we get 4. And now let's put a 3 in there. 3 minus 2 squared times 3 plus 1. So 3 minus 2 is 1. 1 squared is 1. We're going to multiply that by 3 plus 1, which is 4. So we get 4 again. Okay, so let's plot these points. Negative 2, negative 16. Wow, that's really far down here. So I like to take the largest y value, because it's hard to scale your y value before you know what they're going to be, how much of a range they're going to be. So just go all the way down here, make that the farthest y value, and just say that's negative 16, and make everything scale to fit. Okay, so negative 2, negative 16, we got 0, 4. It's going to be about 1/4 of the way of this. So this is right there, so about that far is a 4. So 1 comma 4, there's another point. Okay, so let's talk about this for a second. We know it comes from down here. We know it crosses this x-axis to get to this next point. And what happens? We have a 3, 4. So now we have so much more information than we did before. We know that it's got to come up through here, cross this x-axis, come, maybe it could come higher than that point. It doesn't necessarily have to be at its maximum there. And then it comes down, and then does it cross? No, because if it did, then all the other points would be down here, but we know they're up there. Okay, so there we go. There is a graph of that polynomial. At least a rough one, but a pretty good one. It gives us a pretty good idea of what that looks like. 7. Just another graphing one. All of these are fairly straightforward. They have already been factored, so that makes things way easy. Way easier than having to factor them ourselves. Alright, so if we're going to graph this function, let's decide what the zeros are and therefore the x-intercepts, because that's just an easy way to start graphing a graph. So we'll have zeros at -1. Okay, so we have an x-intercept at -1, -2, and at +1. Okay, actually I'm going to redo that a little bit. Make it a little wider on that scale. -1, -2, and +1. Maybe a little more room in between those. Okay. Like I said before, there's so many graphs that could be drawn in between these two, like this, or like this. Or it could just come up and just touch all of these and go back down. So many silly looking things, so we're just going to plot some points and figure out where to draw our graph. So we'll just, again, split them up into little sections. We want to know what's happening. Does it cross this x-intercept? Does it cross this one? Does it just touch that one? We just need some more points. So here, 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 and here. So we need 4 points. We'll put one to the left. Over here, the easiest probably be -3. In between here, we'll do -1.5. Here, 0 is good. It's nice to use 0. And then over here, we'll go with +2. Okay, let's give ourselves some room. 4 times -3 plus 1 times -3 plus 2 times -3 minus 1. What do we get here? We get 4 times -3 plus 1 is -2. -3 plus 2 is -1. -3 minus 1 is -4. So we got 4 times -4 is -16. Times -2 is +32. Times -1 is -32. And I got 4 times -1.5 times, oh, no, sorry, not that. -1.5 plus 1 times -1.5 plus 2 times -1.5 minus 1. So you have 4 times -1.5 plus 1 is -0.5. -1.5 plus 2 is +0.5. And -1.5 minus 1 is -2.5. Okay. So let's do that. We'll make this a lot easier on ourselves. -0.5 times +0.5. Nope. +0.5. Oh. So -2.5. Thanks for watching me stumble through that. We get 2.5. So 2.5. That's great. We're done with that, so let's get rid of that. 4 times x, which is now going to be 0, plus 1. So let's not even write 0. Let's just write down 2 and negative 1. 4 times 1 is 4, times 2 is 8, times negative 1 is negative 8. Okay, now for 2, 2 plus 1, 2 plus 2, 2 minus 1. 4 times 3 times 4 times 1. 12 times 4 is 48. Okay, well, look at that. That gives way up there at 48. So, like we did before, we'll just put a mark up here way at the top and say it's 48 and scale everything as appropriate. So 2 comma 48, 0 comma negative 8. Let's say negative 8 is kind of there. 0, negative 8. Negative 1.5. Oh, we're going, what am I going, this way? Yes, negative 1.5, 2.5. So 2.5 is pretty small. It's like right there. This barely gets above the x-axis right there. And negative 3, negative 32. So that's negative 3, negative 32. Let's just put it there. Just a rough sketch is just fine. What we know is that it comes up like this. Oh. Cuts through the x-intercept there to get up above the x-axis. That's important. Then it comes down, I think, something like this. And takes back off like that. So there is another function graphed. Next, number 16. And there it is, just a rough sketch of what you see in the book. I tried to make all the numbers match up fairly well. So first, it asks us to find the coordinates of each turning point, or what we called in the, well, what we'll go on to call for the rest of math, extrema. So you got turning points or extrema, whatever you want to call it, but I'd get in the habit of extrema. And those are those in their local areas, the extreme high, the extreme low, the extremely highest spot in this area and the extremely lowest point in this area. Okay. Now there are lower points on the graph, say this one, but not in this area. Okay, so now it wants us to say, are they maximum or a minimum? Well, this one is the maximum. This is the maximum value in its area, so this is a maximum. And this one is a minimum. Right? And they want us to estimate the coordinates of these guys here. So this one looks to be, you know, maybe negative 0.45, close to negative 0.5, or negative 0.5, whatever you're just estimating, and negative 2.5. So there's a labeling of that maximum. This one's a minimum, and let's say it looks like 1.2 comma negative 1, 2, 3, 4, 5.5 or 5.6 or something down there. Right. Next, estimate the real zeros. Okay, we're going to see zeros wherever there's an x-intercept, and here's the only x-intercept right here. And this x-intercept seems to be at 1, 2, let's say 2.45, comma 0. So it looks like our real zero, there's just one of them, and it's 2.45, let's say, just a guess. And then it wants us to say, determine the least degree the function can have. Well, that's determined by the turning points. Okay. You could kind of imagine, and I hope this doesn't mess you up at all, but imagine that the x-axis went, you know, right between all of your turning points or your extrema. You would get 1, 2, 3 solutions, and that would be a degree 3. So let's do that in a different color. the smallest degree would be degree 3. And we know that because there are 2 extrema. There's always one less extrema than, or one less extreme than there is the degree. Degree 3 would have at most 2 maxima. Degree 4 would have at most 3 turning points, or maxima. So that's all that's involved there. We found first we found the coordinates, right? Found the coordinates first. Then second, we stated that they were a maximum and a minimum. Third, we found the x-intercept and thus the 0. And then the fourth thing we did was to state that it was degree 3 at the least. Right? And I'm going to do one more with a warning and a little bit of soapbox. Okay? The soapbox part is I don't love calculators, only because I've seen too many people be crippled by them. They, want to shortcut and cut corners, and it's just sad. It's a sad thing to see. They have beautiful, wonderful, genius minds, and they want to shortcut it by using calculators or computers of some sort. But they're useful. They're very useful to know all the little things you can do with them. So let's go over this. Let's talk about the little tools that your calculator has. But don't let it cripple you. So we have 2x raised to the third plus 8x squared minus 3. Okay, and we want to go graph that. So graph. We wait and we wait. There it is. There's the graph. It asks us to identify the x-intercepts and points where the local maximums and local minimums occur. Okay. Well, here's a useful piece. We can't see this maximum. We can see that it goes up and then comes back down. So somewhere up here is a maximum, but we can't see it. Okay. So I know what I'm going to do, but you could do zoom and zoom out. What that's going to do is just, push out on all axes. It's just going to zoom out like you would think it would. If this were like a camera and it zoomed out, all of the edges would be pushed out so that we could see more of what's surrounding. But we only want to go a little bit further up here, right? So I'm going to go to window, and this is like manually you can go in there and change how far on each axis you want to look. So x-axis minimum, x minimum on the left, right? That's not a problem. The maximum that we're looking at on x is to the positive 10. That's not a problem. The minimum, how far down on the y-axis we're going, that's not a problem. It's how far up on the y-axis that we're looking that's a problem. So I'm going to go up to 15. I'm guessing that's a safe bet. If we push up a little bit more, past where we're looking, up to 15, oh, that's not even far enough. So let's go back, and we'll go to 20. Okay. Alright, that's good. That's great. That looks good. We can see everything. So we want to find first the x-intercepts. There's 1, 2, 3 of them. So I don't like how stretched out this is. So I'm going to go into the y maximum and go to 18. And also, you'll notice that down here, there's a lot of space here. So we might push up on this up to like 5, because we know that this y is negative 10. So maybe we'll push up on the bottom, the minimum y value, up to negative 5. And that didn't cut anything off. So now we can see a little bit better. We might change, just showing you all the possibilities here. We could change the y value so that's not so scrunched. Just kind of spread things out a little. See, now it fits more in the screen. Anyway, find the x-intercepts. So for all this stuff, this x-intercepts, maximums, minimums, we will go to second trace. Above trace is calc for calculate. Calculate a 0. Okay, it says left bound. What is that asking for? Okay, I'm just going to show you the process. You're going to have to reproduce it for the rest of these. Okay, so it says left bound. Okay, so go to the left of the x-intercept, and you can see this will be, the x-intercept is here, so down here would be to the left, right? Everything on the graph past the x-axis here is to the left, so I'll press enter, right bound, go to the right of the x-intercept, that's to the right, and a guess. Just get somewhat close. Just make sure you're not anywhere close to these other x-intercepts. That's all it's asking you to do. It's saying get kind of close, not incredibly close, not painfully close, but just kind of close to the x-intercept and press enter. I'm not even going to move the cursor, I'm just going to press enter, and it's going to tell me a 0 of negative 3.901454. There's a 0. Okay, let's do it again. Second, calc, 0. Where's the left bound? Let's find the next one. Here, I'll start way over here. This is to the left of that 0. And it wants us to go to the right. This, oh, calm down. This is to the right. And I just want to make sure that I'm not too close to this 0. I'll just back up a little bit and go over there. Say, there's my guess for where the 0 is. And it's negative 0.6712857. There's another 0. Let's do the last one. I said I was going to make you reproduce this yourself. And I didn't. Left bound. Here's a point to the left. Here is a point to the right. My guess is right there. And we get 0.57. 0.572733983. Of course, you don't have to write all these. You can go to 3 decimal places. Is plenty of accuracy. And now we want to find a maximum and a minimum. So we go to calculate again. And hey, look at that, maximum. I'll just start on the left and go to the right. So left bound, exactly the same thing. Find a point to the left of the maximum. This one will work. This one's definitely to the right. And what's our guess? Just make sure you get close to the maximum and not this minimum. So, and it's figuring it out. We have a max at negative 2.666669, comma 15.962963. There's where the maximum is. Let's calculate a minimum. We could just press the number 3. Left bound. That's on the left. That'll work. It might take longer that way, but it'll work. And a right bound. And our guess. And we have a minimum. Yes, a minimum at. Okay, so see what it has here. It has 1.07136 E negative 7. Remember, we've talked about this before. This is scientific notation. E means, what does E mean? E is saying at the top of its lungs, times 10 to this exponent. What exponent? The one that's right here. So it's 1.7136 times 10 to the negative 7. So if you multiply something times 10 to the negative 7, it just means move the decimal place that many places, 7 places to the left. So that's what we'll do. So 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7 places to the left. Right, that's this number moving the decimal place 7 places to the left. And the y is negative 3. My guess is this probably is really 0. The calculator is limited. That's why I don't really like calculators, is because you take what they output as the truth when really they have errors, they have flaws. And I'm guessing that this is 0. It could be just slightly off of 0. But it's so small that I'm guessing that the calculator just couldn't quite get it exactly dialed into 0. Again, just a guess. But that should do it. That is the last one. I hope that was all helpful. Thanks for watching.